All right, this is 22 and 23. So 22 is your 1-to-1. You've got one log on either side of the equal sign, right? So we ignore the logs, and we would just take what's next to it. The 4x plus 5 equals x minus 5. Subtract the x. 3x plus 5 equals negative 5. Subtract the 5. 3x equals negative 10. And then divide by 3. And x equals negative 10 thirds. So because my original equation has a log in it, you've got to check. So you can kind of approximate to make life easier, but really what you're trying to figure out is if I take and plug this back into either of these spots, are my logs going to be of a negative number or of 0? So even just in this one, if I have a negative 3 1/3 and I subtract 5 from it, I'm going to get a negative 8, and I can't find log of a negative 8. So that gets ruled out, and it's no solution. Yeah. And then it's here. If it's wrong in either of them, it's a no. Yeah. So if it's this one, it's a little bit harder to multiply it out, but you can check it, right? You would do, like, I could do negative 40 over 3 plus 5, and I can go from there. I know that's going to be negative because it's more than 15 over 3, and then that's a no. So if it's wrong in either of them, or if it would give you a 0 or a negative in either of them, then it's a no. Richard.
Is it the same rule for ln?
Yes. Yeah, because ln is a log.
So it's safe that every time you see a log or ln?
Every time your original equation has a log or an ln, you got to check. Yeah.
Would you take off a lot of points if it was like if it was no solution, but like we put a number, but we just never.
So we haven't discussed partial credit. I'm sure you would get some partial credit. It wouldn't be all of it, but you're definitely going to lose points. You got to check them. So like if it's me and I go to take that test tomorrow, maybe I look through my questions and I find everyone that has a log or an ln in the beginning, and I put a little star next to it. And that's your reminder. There's only 8 tomorrow, so you could go through and you could circle whichever ones you need to know you need to check, and then at least you know you have to go back to those at the end. I would say go through the whole test, make sure you finish it, right? And then go back and check those, because it's better to finish than it is to check those. Does that make sense? Yeah.
So questions without log or ln would they just be questions?
Or they're logs, right? So it's one log on one side of the equal sign, or it's the exponential. Yeah. All right, so then 23, you've got 2 logs on one side of the equal sign, so we're going to condense, but when we condense, it's subtraction, so it becomes division. And then this is 10 to the 1/2 equals x over x minus 4. So then I'd want to multiply by x minus 4, 10 to the 1/2 times x minus 4 equals x. And then, oh, it's not 10, sorry, it's 4. This is 4. That makes it a little bit easier. 4 to the 1/2, right? Because my base is 4. So this is 4 to the 1/2, which is 2. Then distribute your 2. 2x minus 8 equals x. I can subtract the x that way. And x equals 8. So when I get that answer, because this has a log in it, I need to check. If I plug an 8 back in here, it's fine. It's not 0 or negative. If I plug an 8 back here and then subtract 4 from it, it still stays positive. So I know I get to keep that answer. Yep.
If it was like a 10, like how would you go?
This would be calculator based, and I would keep it as 10 to the 1/2 as long as I could until the very end. Yeah, because that wouldn't be a perfect square root. Yeah.
So if it's 4 to the 1/2, it wouldn't be plus or minus?
No, because it's not x squared equals 1/2. You're square rooting that number. So when we bring in the square root to the problem, when we use square root to get rid of a squared, that's when we do plus and minus. If it legit says at 4 to the 1/2, that is just the square root of 4. Okay, this is, what number was this? Oh, I cut it off. Who was next? I don't remember. Is this yours? Yeah. Okay, so solve exponential algebraic. Oh, yeah, no, I don't know. It says 9, so this is a great calculator-based question that would be on something you could see for tomorrow. 10 to the 8x equals 12. I see that it's exponential, so I don't have to worry about checking this answer to rule out an extraneous at the end. I know I need to get the exponential part by itself, so I'm going to divide both sides by 9. 10 to the 8x equals. Now I can reduce 12 over 9 because 3 goes into both of those. I couldn't make it 4/3, or you can leave it 12 over 9. It doesn't matter. You're going to put it in the calculator at the end anyways. Now I have 2 that the bases can't be made the same, so I'm going to ln both sides of my equation. ln of 10 to the 8x equals ln of 12 over 9. Be careful and make sure you're finding the ln of that whole thing, so they both would be in the parentheses. Now I would bump the 8x to the front. 8x times ln of 10 equals ln of 12 over 9. I can divide both sides by 8 and ln 10 all at one time, leaving just the x by itself. And then I plug that whole thing in the calculator. So ln 12 divided by 9, close my parentheses, divided by 8, and I have to group it. Parentheses 8, ln 10. So in the calculator, it looks like ln, open the parentheses, 12 over 9, close the parentheses, divided by, open the parentheses, 8, ln 10. There's a parentheses here too, okay? You got to make sure you group the denominator because there's two things in it. And from here, I get 0.0156. It said to round to 3 decimal places, so this is going to bump this, 0.016. Yeah. That's not yours? Okay, so then okay. This says 3 to the 8x equals 90, so it's already exponential, and they can't change the base. So I would ln both sides. So ln of 3 to the 8x equals ln of 90. Bump this forward, 8x times ln of 3 equals ln of 90. Divide both sides, and you can do them both together, 8 and ln of 3. Cancels, x equals, and then I'm going to type it in. ln, it's going to open the parentheses, 90, close the parentheses, divided by, open the parentheses, 8 times ln, and it's going to open the parentheses, 3, close them again. So ln 90, close them, divided by, open, 8, ln 3. And I get 0.5119. The 9 bumps up the 1 to make it 0.12. You're welcome.
If you put an extra parenthesis after the parenthesis after 3,
It doesn't matter. You don't even actually, when it's the end, you could leave them all off. So when it's the very end, the parentheses don't matter. It's not like you have to complete it.
Would it be wrong if you did ln 90 divided by ln 3 first and then you divided by 8?
Yeah, you mean after you bump the x to the front? No, not at all.
Like
So you do this in 2 steps.
Yeah.
No.
Okay.
And you could do it divided by 8, then divided by ln 3. You could do it divide by ln 3 and then divide by 8.
Get the same thing.
Yep. You just want to keep those answers exact in the calculator. Keep building off of the answer before it instead of rounding. All right, this was 20. So now I've got 2 ln's on one side of the equal sign. I'm going to condense. So ln of x over x plus 1 equals 8. I change this to log base e of x over x plus 1 equals 8. The e comes over, picks up the 8. And I get e to the 8th over x plus 1 over x plus 1. I got to multiply both sides times x plus 1. And this is that one of the scenarios in which you have an x on both sides, right? So this is the crappy one because we have to distribute and then move. So we're going to distribute e to the 8th times x plus 1 times e to the 8th equals, these canceled, and I get x. I got to move both terms that have an x to one side and the other one to the other. So I can move this e to the 8th with the x over here, or I could have gone the other way. X minus e to the 8th x. And then I got to take out an x. This becomes 1 minus e to the 8th equals e to the 8th. And then we divide both sides by 1 minus e to the 8th. And in the calculator, I would do e to the 8th divided by, open your parentheses, 1 minus e to the 8th. And I get negative 1.0003. So it's just 1.000. It said to round to what? So then I would check this, right? Because my original equation has a ln in it, which is a log. If I plug in a negative 1 here, I can't do it. I plug in a negative 1 in here, and I still can't do it. So that's why it ends up being no solution. Okay, 21. So now I've got logs or ln's on both sides of the equation. There's multiple ones on the right. I have to condense the one on the right, so I'm going to get ln of x plus 4 equals ln of x minus 5 over x plus 5. I have an ln on either side of the equal sign, so I can rule it out and use the one-to-one property. I got to multiply both sides by x plus 5 to get rid of my denominator. If I FOIL this out here, I get x squared plus 9x plus 20 equals x minus 5. And as soon as you see that x squared and the x, you know you're going to have to factor. So I'm going to move the x over here and move the 5 over here. And I get x squared plus 8x plus 25 equals 0. There's only, it said to round this, right? There's only 1 and 25 and then 5 and 5 here, and none of them add to 8. So you'd actually have to use the quadratic formula on this one. No, you don't have to use the quadratic formula. But when you get there, you get, I think you get to negative, no, you get a negative, but it's, or positive, but it's small. So here, I'll work it out. But you're not going to have to do quadratic tomorrow. Negative b plus or minus. Oh, this is why it doesn't work. You definitely can't use an imaginary number. So that's why it's no solution. Next one, so here's our factoring one, right? So e to the 2x, and there's one, the one on the review says 2z. It should be x. I'll show you that in a minute, but e to the 2x minus 7, e to the x minus 18. So I'm just going to factor it. The first term would be e to the x in each set of parentheses, and then I'm looking for the factors of negative 18 that sum to negative 7, which are negative 9 and 2. Subtract the 9, add the 2. Now I split and solve these, and I get e to the x equals 9, and e to the x equals negative 2. And then we've got to ln both sides of these equations. I get x equals ln of 9, and I get x equals ln of negative 2. Yeah.
What did you do with the 2? The 2x?
What 2x?
E.
Oh, it just factors. So when you split that, that's e to the x times e to the x. So that's that first term. And that will happen every single time. So ln of 9 is 2.197, and then ln of a negative number doesn't exist. So my answer is just that 2.197. Yep.
Is that one of the ones that you can use substitution?
Sure, like you can make a e to the x. Absolutely. Yeah. All right, last one, ln x equals negative 6. So the ln of x turns into log base e of x equals negative 6. And then the e picks up the negative 6. E to the negative 6 is 0.0024. So I get 0.002. Check it by plugging it back in, and you can find it's small, that 0.002, but it is bigger than 0, so I know I get to keep it. Any other questions from the homework? Yeah.
When I plug e to the negative 6, oh sorry.
It's okay.
When I plug e to the negative 6 in my calculator, I get like 2.46.
So for tomorrow, you're going to need both. A equals P times 1 plus R over N to the NT. This is like the ending balance. P is the initial amount. R is the rate in decimal form. So if I gave you like 2.3%, you got to move it 2 places to the left. N is the number of times a year. So if it said like monthly, that's 12. Quarterly, that's 4. Weekly, 52. Daily, 365. What else did it give you? Like semi-annually is 2 twice a year. And then the T is the number of years. And then the other one you need to know is the PERT. A equals P E R T. The A again is the ending balance. The P is the initial. The R is the rate in decimal. And the T is the time in years. Yeah. From the review? Yeah. Okay, so this, like, remember yesterday I said it looks like it's so complicated. It's just a factoring problem disguised as exponential. So you can choose to either, this should be e to the x. Wow, that should have been like that. There's 2 typos there. That should be e to the x. So it should, the question should have said e to the 2x equals e to the x. And then it's your factoring one. So when I factor this out, e to the x would be e to the x times, e to the 2x, sorry, would be e to the x times e to the x. So that goes in the first spot, and that always happens. And then you're looking for the factors of positive 5 that sum to negative 6. So negative 1 and negative 5. And then we split and solve this. E to the x equals 1 and e to the x equals 5. And then there's 2 exponential questions with e's, so we ln both sides. Ln of 1 equals ln of e to the x becomes just x, and ln of e to the x becomes x equals ln of 5. Ln of 1 is 0, because anything that results as a 1 is 0, but if you don't know that and you type that in the calculator, you hit ln 1, it's going to give you 0. And then ln of 5 is 1.609, so I think we said 3 decimal places. So 609. Your test is 2. Yeah.
What do you do on the test? Like, you don't have to round up. You just use the decimal as it is.
You can truncate it or round. Yep, you could do either one.
Why would it the equal that? I mean, why would the 0 equal that?
Because it's not log. It's exponential. So you can raise e to the 0 power, it's 1. You just can't log 0. So if, like, that's what I, like, when I get the, if I'm you and I get a test tomorrow, I would look through all these questions. There's no logs in there. Then I would, this is 17. So you've got 1 log on the left and 1 log on the right, but it's not by itself. It's got the number. So I have to group the logs. I have to move this log, and it doesn't matter which way you move it, but I'm going to move it from the left to the, from the right to the left. So I end up with log 11x plus 9 minus log x plus 3 equals 3. Then I've got 2 logs on one side, so I got to condense. It's division, so it becomes subtraction. And then our base is 10. So 10 comes over and picks up the 3. And I get 1,000 equals 11x plus 9. So you technically don't need a calculator on this number. If that was a smaller number, you might get this without the calculator part. I only gave you the calculator because it's 1,000, and then you got to multiply, and then you got to divide by like 990, like whatever it is. If that was something like 10, you could do it without. So I would multiply by x plus 3. You're going to distribute here 1,000x plus 3,000 equals, these are gone, 11x plus 9. And then you can subtract the 11x. So this is what I'm talking about. Like if that said 10, you would be able to do this without a calculator. This is 989x equals, subtract the 3,000. Negative 2991. And then you got to divide both sides by 989. Negative 2991 divided by 989. And I get negative 3.02. But the original question has logs. So you got to check. As soon as I check this one, I end up with log of negative 3.02 plus 3. That's going to give me a negative, which means you rule it out.
Okay, I put positive 3.02.
Oh, okay. Just watch your sign. Sure. What was the last? Oh.
Is number 19, like we have to like factor out both sides? Not factor, but like distribute
Yep.
both sides. So it's like 4 things on each side. I'm sorry, 2 things on each side.
And then you got to move the x's and then move the none. And you're definitely going to see something like that. Like, remember I taught you, like, that was the most complicated, like that one. And what's the other one where you have to move them? The e's are like that. Go to whatever's after that, like which one's here. I got a log, which means I have to check this answer. Keep going to LN. Okay, so 27 says, what annual interest rate to the nearest tenth will produce $5,760 if $3,500 is left at an interest compounded annually for 10 years? So annually tells me that this is not continuously, right? Like that's, you want to look for that keyword, which means that A equals P times 1 plus R over N to the NT. From the information, I know that 5,760 is the A, 3,500 is the P, 1 plus the rate is what I don't know. The N is number of times a year, and if it's annually, that's once a year. And it says for 10 years. So number of years times the number of times a year times the one time a year. All right, so I can actually 5760 equals 3,500. R over 1, I can simplify that to just 1 plus R, and then to the 10th. So I just made it a little bit easier because dividing by 1, it goes away. Now I've got to divide both sides by 3,500. So I can simplify a little bit. 5760 over 350 would equal 1 plus R to the 10th. Now, you can't ln this time because the exponent doesn't have the variable. So if you had tried and like done ln here and ln here, you'd get ln of 576 over 350 equals, and 10 could bump to the front, ln of 1 plus R. But I can never break that up. Because the variable's inside with that, you actually have to just go back to like before we even ln things and look at this as though it's something raised to the 10th power. So if I wanted to get rid of it, oh, actually, I think I did this differently. Hang on, I'm trying to remember last night. No, I did. You got to 10th root it. So I actually, like if that was square rooted, if it was squared, I would square root it. I'm going to 10th root this. So if you have never found the 10th root button on your calculator, it's in a weird spot. It's under the math button. I'm not going to type it in yet. I'm going to keep it exact, but I would get the 10th root of 576 over 350 equals, and now this cancels, and it's 1 plus R. So the last thing I would do here is subtract 1. So in my calculator, I'm going to do the 10th root of 576 over 350 minus 1. So like I said on the graphing utility, if you go to the math menu, the fifth thing in the line is x with it looks like this, x square root, like that. If you click there, it's going to give you a little box here, and then it gives you a box here. So it's going to let you put the index in, which would be 10. And then underneath the square root, I'm going to put the 576 divided by 350. And then to that, I'm subtracting 1. And I end up with R equals 0.051. Now that's in decimal, right? But it needs to be in percent when you give the rate. So I'm going to move my decimal 2 places to the right, and this would be 5.1%. Wait, say that again?
717.
The highlighted ones, those are all your interest ones. The one at the top doesn't have a log in it. Those two that if they start with a log or an, these are all properties. These don't have any. Yeah, that's it. That's on the review. It's just that